part 2 of chapter 4, that is about capacitors and dielectrics. We focus on parallel plate capacitors, everybody, and different circuits. So capacitors can be connected, everybody, in parallel, and also they can be connected in series. We will consider each one of them separately and of course their properties. Capacitors are connected in parallel. So have a look to this circuit, everybody. Assume we have two capacitors or three capacitors, something like this, they are connected in parallel. What does mean if we say capacitors are connected in parallel? Here we have a battery. Assume you will close the switch S somewhere here. Switch S is closed. Then everybody charges will flow through the wire. They reach to this junction point. This is called junction. So what happens? Some of the charges will go through this path, some of them here, some of them over there. We have Q equals CV. Therefore, everybody, charges on each plates are different. Therefore, if it is C1, this one is C2, this one is C3, this one will acquire some charges such as Q1, such as Q2. This one charges Q3, in which we can write Q total equals Q1 plus Q2 plus Q3. However, about the potential, everybody, potential on each these two plates will be same as potential of the battery. In fact, we should write V of battery equals V1 equals V2 equals V3. This means your capacitors are connected in parallel. Okay, if a capacitor, everybody, if some capacitors are connected in parallel, C equivalent, if you remove all three capacitors and substitute one capacitor instead, equivalent capacitor can be calculated by normal sum of each capacitors. Okay, everybody, these two rules are important. In fact, you have to realize on each point how much is the potential and how much is. Okay, we have three capacitors, everybody, in series. Assume these are connected to a potential of V battery, something like this. This one is C1, C2, C3. Then it becomes a starts charges being in move here. They are moving. And then since this one is positive terminal, it makes this plate positively charged. This one is negative terminal, then makes this one negatively charged. Here, everybody, between the conductors, it is natural. They are in equilibrium. However, when it is negatively charged, it keeps same amount of positive charge to this terminal. Then this one, this plate, will become positively charged. It takes all the same amount of charges, but negative here because of the existence of the electrostatic attraction. It attracts again here positive charges. Here we will have negative charges. If this is Q1, Q2, Q3, we can write, everybody, Q total in the circuit equals Q1 equals Q2 equals Q3. This is the meaning of capacitors in series. Means each capacitor has the same charges if they are connected in series. What do you think about the potential? V here, some potential gets used across the first capacitor, some potential gets used across the second, and we have the third. Therefore, V equals V1 plus V2 plus V3. You always should care about these two equations, everybody. Okay, once you substitute this into the main equation, Q equals CV, then you can get the last answer. In fact, equivalent capacitor, everyone, equals to this. You may have this equation. However, be careful. Once you use this equation, you will receive 1 over C. Uh, if you use this equation for two capacitors, everybody, for two capacitors, this is the battery V, C1, C2, C equivalent equals C1, C2 over C1 plus C2. For two capacitors, we can use this equation, everybody. But pay attention, here you directly derive CQ, but here you derive 1 over CQ or C total. We have an example here. Three capacitors, everybody, are connected in series. Potential V is the potential of battery. If a charge of Q flows into this combination, how much charge does each capacitor carry? So V of battery, everybody, is 11 volt. And capacitances are given as 1, 2, 3 microfarad. What's your job right now? First, you have to calculate C total. Capacitors are connected in series. Then the last equation will be used. So this is 1 over C. C, everybody, equals 6 over 11 microfarad. Q equals CV. Q total, everybody, is 6 microcoulomb. So up to here is easy. The important part of this type of questions, everybody, is if you have three capacitors, you must be able to fill 6 empty places. In fact, I'm talking about something like this. C1, it's important to calculate Q1. It's important to calculate V1. We have the same thing for Q2, V2, Q3, V3. Okay, we must calculate these six things. This is important. Okay, how it is possible, everybody? We got Q total. Q total in the circuit is 6 and capacitors are connected in series. What does this mean, everybody? Means, according to our discussion, once capacitors are connected in series, Q total equals Q1 equals Q2 equals Q3. Therefore, this is 6 microcoulomb. This is also 6 micro. This is also 6 micro. Once you get one of these empty places, the answer of this point means this empty point, it is possible to calculate the other one by equation of Q equals CV. So V1, everybody, is Q1 over C1. That is how much? 6 over 1, it's 6. This one is 6 over 2, that is 3. This one is 6 over 3, is how much? 2. Okay, you can check validity of your answer, everybody. How? If the capacitors are connected in series as this question, V equals V1 plus V2 plus V3. Okay, therefore it should be 6 plus 3 plus 2 is how much? 11 volt is the potential of battery. Now we assume capacitors are connected in parallel, everyone, something like this picture. Now you should be again able to fill in these three empty points, Q1 V1, Q2 V2, Q3 V3. Okay, have a look to the answer about the total capacitor. Okay, C equals C1 plus C2 plus C3 is 6 microfarad. This times everybody, potential is 10 volt. Q equals CV will be how much? 10 multiplied 6 is 60 microcoulomb charge is existing in the circuit. Now what do we have? Charges are not the same. They follow by this equation. However, what we have some more information, everybody. Since capacitors are connected in parallel, means we have potential of each one separately. In fact, V1 is 10 volts, V2 is 10, V3 is also 10. Then you can get everybody Q of each one of them, which has been calculated. You can check the validity. 10 plus 20 plus 30 is how much? How much, everybody? It should be 60 microcoulomb, as we got Q total as 60. You can check validity of your answer. Okay, in this question, everybody, we have a circuit, something like this, which is made by 3 capacitors, 2 of them in parallel connected to another capacitor in series. Assume the amount of each 3 capacitors are the same. It is shown by C. In the part B, everybody, we can see the capacitance is 3 microfarad. What's our job right now? First, we have to calculate CEQ equivalent. Okay, between these two, everybody, we have to first look at this branch. It is called, everybody, C23, just by abbreviation. We can call it C23. Okay, these two capacitors in parallel, then normal sum 2C. This one, C23, which is 2C, is connected to C1 in series. Then we can calculate C equivalent by this equation. C equivalent, everybody, is 2 over 3 C, in which C is 3 microfarad. C is 3 microfarad. Therefore, everybody, C equivalent for this question is 2 microfarad. If everybody's CQ is 2 microfarad and the potential is 2 volt, how much is the total charge? Okay, 2 multiplied 4, it gives you 8 microcoulomb charge is existing in the circuit. The important thing, everybody, as I told you, is important to calculate Q1 V1, Q2 V2, Q3 V3. Okay, have a look to the last answer. So we have Q total, everybody, is 8. V total equals how much? 8 over 3. So what information this tells you? In fact, you have to look at the circuit in the last step. We have to make another bracket, everybody, that is about Q. Charge accumulates on the capacitor 2,3 and the potential of 2,3. How much is this? So, in fact, everybody, these two capacitors are connected in series. Therefore, the total charge equals the charge of Q1, that is 8. It also equals the charge on Q23. In fact, the charge of the capacitance, which is indicated by the index 23, is 8 microcoulomb. Once you get, everyone, this 8 Q or this blank, once you found it, it is possible to find the potential by having Q over C. In fact, 8 divided by how much is C 2, 3 is 2C means 6. In fact, 8 over 6, that means 4 over 3 volt is the potential existing here. Okay, have a look to this case, everybody. Charge is 8 microcoulomb, then potential is 8 over how much? 3 volt is the potential across C1. In order to find the potential and the charge of Q2 and Q3, you need to look at this last answer about the bracket, about the Q23. Okay, what does this mean, everybody? In fact, these two capacitors, 2 and 3, are connected in parallel. C2, C3, something like this. Okay, once we have potential C23 as 4 over 3, this means potential of each one of these two capacitors are same as potential of the total. In fact, V2, everybody, equals 4 over 3. V3 is also 4 over 3. Once you get this as V, it's possible to calculate Q. Q2, everybody, equals C2 V2. C2 is how much? C2 is 3 multiply 4 over 3. It gives you 4 microcoulomb charge is existing here. So same scenario since the capacitances are the same. So everybody, what is existing? Oh, sorry. This is about here. Same for the charge Q3 is 4 microcoulomb. Okay. Now everybody, there is the relation between Q2 and Q3. In fact, Q2 plus Q3 equals the total Q 8 microcoulomb. You can check the validity of your answer, everybody. This all the equation. Here we have another nice example about this topic when capacitors are connected in series and parallel, everybody. So we have this combination of capacitors and the amount of each capacitor is given. Here we have two switches, S1 and S2. So if part A, they ask you if only the switch S1 is closed. Okay, when S1 is closed, means here is closed. This one is open, then you can ignore it. You can ignore it. And our circuit will become such as this. In fact, C1 and C3 are connected in series. This one is connected in series. Then we have something like this. This one is called C prime, C double prime. These two are connected, everybody, in parallel. This will be our circuit. This will be our battery. However, C prime can be obtained by this equation. C double prime can be obtained by this. And then C total is the normal sum of the two. Q equals Cp. Q total can be obtained by the same scenario as I did in the previous slide. You do the same for understanding how much charge or how much potential across each one of the capacitor you can calculate. It's important, everybody. This is part B of the previous question, everyone. Both two switches S1 and S2 are closed. Then our capacitor, the combination will have this form in which, everybody, we can call it C1 and C2 has been called C prime. This part, everybody, is called as C double prime, in which there is this form between. In fact, C prime and C double prime are connected in what? series, you do the same calculation, everybody, and you can calculate uh, Q total in the circuit, and also potential and charge existing on each capacitor separately. One more example about this topic, everyone. So we have this combination. First of all, in order to calculate CQ, you have to have a look to C5 and C3. These two capacitors are connected in series. So then you can remove them and substitute one instead this. Then we will have here something like this, that is called C5 tree, means combination of these two capacitors are connected with, this one is C2. We have one more here, C4. Once you solve this part, everybody, then this is called C prime, as I see here. C prime over there, we have also something like this as C1 and C6, as we can take it as C double prime, and then C prime, everybody, and C double prime are connected in series. This is potential of batteries. Step by step, everybody, you have to make simplification on your okay, this is the domain of the previous question, everybody. All the potentials and charges have been calculated. Okay, we have one more nice question about this topic, everybody. So in this figure, this is our battery. We have two different branches by different capacitors, everybody. However, value of each capacitor is the same. Here, if it is C, this one is C, C, all of them C, same amount. However, this point here is called A, this one is B. They ask you calculate the charge and potential of these two capacitors, which is indicated by A and B. However, value of the capacitance is the same. What's your job right now, everybody? You have to do the best simplification. Of course, it's not possible to work like this. So the first step about the connections, everybody, and junction points, you have to be careful. I started from here. This is point A. I drawn here. We have, it is called, everybody, I name each capacitor separately. This is number 4. I can show here. This is number 5. And this one is number 1, which is series with this branch. Okay, in fact, capacitor number 1 is connected in series in this branch. However, this total branch and this one are connected in parallel. Okay, this one is number 1, and this is alone here because here we have two junction points. This is number 2, this is B, and this is, take it, number 3. Then you can compare with this one. This is the simple form of this circuit. Then you follow the recipes and then calculate CQ and the other unknown. Here also we continued with the question. I invite you to study and try to understand how I get these answers. Thank you for listening.